and not just what it is, more specifically, what is disaster recovery as a service, what do you get out of it, and what can we provide for you? First, just a very quick overview of Greenhouse Data, what we do. We were founded back in 2007, and we are headquartered out of Cheyenne, Wyoming. Today, we have multiple facilities, 2 data centers in Cheyenne, Wyoming, as well as 3 in the Pacific Northwest, 1 in Portland, Piscataway, New Jersey, and Orangeburg, New York. We are highly process and procedure driven. We are PCI compliant. We are HIPAA audited every year, put a big focus on that. We're a VMware service provider shop primarily, which you'll see focused in a lot of our disaster recovery products. As you can tell by the name Greenhouse Data, we are very energy efficient, wind-powered, EPA partner, and we're also a B Corp. The other thing that sets us apart from other service providers is that we offer 24/7 live customer support. Here's a little diagram showing where we have some of our data center locations. And now a little context surrounding disaster recovery. This is a quote from Gartner. Disaster recovery as a service is mainstream now, rapidly growing from 18,000 disaster recovery as a service production instances to over 30,000 in 2015. Now in 2016, we are even higher. So you can see how important it is to incorporate disaster recovery into your data protection solution these days. So what is disaster recovery as a service? In a nutshell, it's recovering critical portions of your IT infrastructure into another location where you can get that up and running. It's not just data protection, having that off-site where it's protected and can be recovered. It's getting that infrastructure up and running, and it's also doing it as quickly as possible. You know, everyone has different requirements when it comes to disaster recovery. That could be a day, a week, but for most people and most businesses, their crucial applications is what the business runs off of, so they need those to be available right away so their employees can keep working, so their customers can keep accessing their servers. And then it's also being able to resume operations. Once you're running out of a disaster recovery facility at a service provider and your primary facility comes back online, you're going to want to be able to resume your operations back there at some point when that's available. So what are the challenges with disaster recovery? First of all, that you need a secondary set of infrastructure to run your workload. Say you have a VMware environment in your office, traditionally you would need an entire another VMware environment in a service provider's location. So that would require the compute host, the storage, the networking, the internet capacity to already be there. Another is that most companies don't already have a secondary location, especially if you're a small office. If you have a remote office, it's probably not well suited for a data center with redundant power and appropriate cooling. And then last, disaster recovery solutions themselves, the actual software or hardware required to get data from A to B, can be very complex and very expensive. And then many IT departments also don't have the staff to handle a disaster. You know, they're busy with the day-to-day business, which when you fail over to another facility, those duties don't go away. You're still going to have those, and they're probably going to be more tasked with getting employees and customers rerouted to the new location and putting out any other fires that may have arisen in that disaster. So then, more specifically, what is disaster recovery as a service? In a nutshell, you're leveraging a service provider to help you with all these challenges that we just identified. That can be everything from starting with the design. I have this type of infrastructure, because no two environments are ever built the same. It could be physical, could be virtual, could be VMware, could be Microsoft Hyper-V. How do we actually design this disaster recovery solution? How do we set it up? How do we configure it? And probably most importantly, how do we test it and test it as a regular basis so you can feel safe knowing that this actually works? Disaster recovery as a service also allows you to bring these enterprise class solutions to small and mid-sized businesses. So as we mentioned before, especially if you're a small business, a lot of those challenges are going to be cost related. You can't afford to have these solutions that are traditionally tens to hundreds of thousands of dollars because it's not in the budget. By leveraging cloud scale computing, you don't have upfront hardware or software costs. Software can be leveraged on a monthly recurring basis, and instead of hardware, you can use scalable on-demand cloud infrastructure. And then as we mentioned earlier, such as our support philosophy, you can rest assured knowing that you have customer support at the service provider location 24/7, 365. If it's 3 in the morning, on Christmas morning, that if you have a disaster, someone will be there to help you fail over your infrastructure. So let's look at some of the common reasons for outages. If you look starting at the top right, you'll see that accidental deletion of data and software issues and malware make up less than a quarter of your the reasons you would actually have an outage. And these are both issues that are normally handled by a backup software. If you look at the other areas, such as natural disaster, power loss or interruption, and hardware failure, those are things that your backup's not going to help you with, because I mean, if you have a hardware failure, you don't have hardware to restore your data back onto. If you have power loss interruption, your backup system may also be offline. So this kind of shows you that backup may not be the answer to all of your data protection needs. So digging into those issues a little more, we like to stress that DR is not backup and backup is not DR. They serve different purposes. Again, your backup is aimed at individual files and databases that you would be able to restore granularly, whereas disaster recovery is going to protect you in an actual disaster, whether that's a fire in one room, you lose a whole building, a flood, something like that. And then we think people should ideally leverage both. And here's a little table that illustrates why. First is going to be retention. Backups are traditionally performed at regular intervals, which means you can keep a lot of versions of that on site. A lot of people have like a daily, weekly, monthly, maybe even yearly backup retention. With disaster recovery, data is usually sent synchronously. That means that you have a lot of more points in time that you could fail back to, which also requires more data. So traditionally, we recommend that people use their disaster recovery to protect the last 14 days. That way, if you get something like CryptoLocker, don't notice it until Monday morning, you can go back into Thursday evening at 9 p.m. You can go to a very specific point and actually fail over at that point instead of having to restore all this data from your backup. The other is going to be versioning, and that kind of goes back to the retention policy. With backup, you're going to want to have the last 20 versions of this spreadsheet so you can go get a, pull back a specific version, again, from 2 weeks ago if you want. Whereas disaster recovery, you don't need that. You're focused more on not just the individual files, but the versions of the server itself that you could recover, which kind of brings us into the restorability. Again, backups, individual files, I lost that spreadsheet, whereas disaster recovery is going to protect the whole server. And then last is the recovery time. Backup can take hours to days if you have an actual disaster. And that's because there's a good chance your server is lost with it. You can't just restore file data into thin air. You have to have a server first, and that could be purchasing a new server and racking and stacking it. It could be building a new VM and then installing SQL before you can restore that database, for instance. Whereas with disaster recovery, you are recovering the entire server, so you don't have to have anything in place ahead of time other than the infrastructure itself. Next, I've talked about some of the different recovery objectives that we just mentioned. Recovery time objective, or RTO, is usually the biggest area we focus on, and that is how long until your entire infrastructure becomes back up and running. So going back to our backup versus DR comparison, backups can have that high RTO because you might have to build the server first, whereas DR has a quick RTO because it's just restoring the entire server. And usually, when you're recovering from disaster recovery, your data doesn't have to be moved or copied like it does with backups. It can just be brought online in the current state, making it sub 5 minutes versus 5 hours. The next is recovery point objective. Recovery or RPO is going to be how long it takes data changing in the source to make it to your DR site. So looking at backups, if you do a backup once a night at 10 p.m. and your site fails the next night at 9:59 p.m., Well, your RPO is 24 hours because no data has been moved since then. Disaster recovery solutions have a very low RPO because data is being transmitted synchronously. So it could be every 5 seconds instead of every 24 hours. Another way that we push people to look at recovery point objective is just how much data can you afford to lose. If you can afford to lose the last 24 hours of your operations, well, then maybe your backup will work. But if you have something like a highly transactional database and you need those constant writes, you want something with a low RPO. And then the last here is recovery service level. And the recovery service level is what percentage of your production environment does your DR need to run at? So again, a couple of ways to look at this. One could be, I have 20 production servers, but only 5 of them are actually critical to keeping my business up and running. So to keep costs down, I'm only going to replicate those 5 to my DR site so I can get them up and running first, and then the other 15 we can get up and running in subsequent days, the next day, week, month, as it's needed. Another way you can look at it is just an overall percentage of your production capacity. So maybe I do need to replicate all 20 servers, but they can run with half of the resources in a disaster. So I know that my applications are probably not going to be as responsive. It's going to be looking at the web pages might load slower for my end users, but everything's up and running and it's available. And I know that this is only temporary because eventually we're going to be able to revert back to production. Or using cloud scalable infrastructure, if you're not able to move back in quickly enough, you can just increase those resources and maybe take that recovery service level from 15% back up to 100%. So these are all factors and all questions that we ask people when we're trying to put together a disaster recovery solution, because no business is the same and no solution is one size fits all. All right, now let's look at types of DR environments. First, going to be a cold site. This is usually going to be the cheapest, the easiest to implement, but it's not actually going to be give you the best protection. So this could be an infrastructure as a service environment that's just sitting with no configuration in there, no virtual machines running. This could even be like I have data center cabinet space at this location 100 miles away, but there's no actual servers in there. So in most cases, you don't even have the data on hand. You just have an area available to recover into if you need to. A hot site's going to be the opposite. So it could be that infrastructure as a service or co-location deployment, but you do have servers ready. You have internet provided, your firewalls are configured, and you even have that recovery data on site. That's what allows you to basically get up and running the quickest, but obviously at a higher cost. And then another kind of philosophy towards this, which may not be just disaster recovery related, but part of a business continuity plan, would be an always-on configuration. This is going to be where you have infrastructure always running, always in sync, and usually always being accessed. So maybe I have a website that I want to be highly available. I might have a web server on the East Coast and a web server on the West Coast. And then by using a load balancer or a content distribution network, my users are automatically rerouted to, well, whichever one is online, or maybe even the one that's closest to me. This is what you're going to see a lot with, for an example, like Netflix. When you go home and log into Netflix, you're not going to one data center location, and if they have problems, they're not going to fail over to another location. They have a distributed network around the country. So now let's look at some of the different types of DR solutions. As I mentioned earlier, no two companies have the same requirements, just like no two companies have the same infrastructure. If you have a larger infrastructure, one of the solutions we might propose is called a storage-based solution. These often predate virtual environments when people would have something like an AS400, like a mainframe or a SAN in their office that had all of their data on it. The easiest way was to basically put a similar device in a target environment and replicate that data from A to B, doing LUN level replication or data store level replication. These are still available to us. The drawback to storage-based solutions is that you often don't get the granularity you need, unless you're using, potentially expensive solutions like Site Recovery Manager that can do, really specific orchestration for you. The next and probably most common one we work with these days is a hypervisor-based one. So instead of looking at the storage on the back end, like just an entire LUN or data store, we're looking at individual virtual machines in a virtual environment. Common ones we use is Zerto and Veeam. Benefits to these, again, is that you can leverage cloud scale architecture. You're not deploying an entire virtual environment in another location. You're protecting your primary dedicated private cloud and pushing it up to a public cloud infrastructure. I mean, you certainly can do the private cloud, and some workloads and requirements do demand that, but in most cases, you can just recover into the scalable cloud infrastructure. The other benefits to a hypervisor-based solution is that it only cares about the virtual machine. It's not looking at the brand of server that you're running your compute workload on. It doesn't care about the type of switching, even whether it's 1 or 10 gig. It doesn't even care if you have different storage solutions on the back end. So again, you could have EMC on one end, NetApp on the other. To the solution, it's just a virtual machine, and it just needs to know how to get from A to B. And then lastly, software-based solutions. Back before virtualization, people still had disaster recovery needs. And when they had a physical server sitting in a rack, we needed something to be able to capture that. Maybe that data wasn't on a SAN. It was all just contained in this one box. That's where we actually use software-based solutions. The most common we use is double take availability. It actually sits at the operating system level, looks at all the byte level changes, and replicates it over to a target. Now, in most cases, if we're doing like a physical, we can do, if we're replicating a physical server, we can do a physical to virtual replication. That way you don't have to purchase another server and rack it in a data center location. You can, again, leverage cloud infrastructure. And then when you have the failover, it'll basically bring up that image online on the virtual machine and continue as if nothing ever happened. So a very, very convenient tool that we still use these days when we run into physical infrastructure. All right, now, one big consideration in a DR solution is going to be bandwidth. This is actually something that I think is one of the most important and yet overlooked areas. So everyone wants to know, how much is the software going to cost? How much storage do I need? What is the infrastructure going to be? But you can get all that into play and then find out that you don't actually have enough bandwidth to get the data over there. And there's two sides you have to consider that. One is going to be at the target, or at the target side. That would be us, the service provider. But we usually have ample bandwidth for everything our customers need. The more important is at the customer side. But yeah, again, do you have enough bandwidth that you can get your data off-site and that it's not going to impact production? So to put some numbers into context, let's say you have a terabyte of data, which honestly is not very much by today's standards. And 5% of that data changes in a given day. That is 51 gigabytes a day that has to move. And it averages out to 4.8 megabit per second over a 24-hour window. Now, most internet connections, even at a business level broadband, are not going to have symmetrical upload and download speeds. And one thing to really, that people overlook is that if you are seeding data, if you're replicating data off-site to a service provider, you're leveraging that upload speed of your facility. Like I can speak personally, at my home internet is 60 megabit down, but only 3 megabit up, so it's considerably slower. Another thing to consider is that data is often written in large chunks. If, it would be nice if that data, that 51.2 gigabytes there was slow, just evenly written out over a 24-hour period, but that's not realistic. If someone comes and writes a large file to a server, that large amount of data is going to queue up and try to transfer over to the DR site all at once, and that can cause a bottleneck. Now, the bottleneck, the data will get queued up. It'll get there eventually, but it can cause your RTO time to fluctuate while you're waiting for that data to get there. And then another thing to consider is that bursting of replication can take away from other production operations that you have going on. If you run a website out of your same facility, that could actually affect how well your web server is able to serve pages to your users if it's on the same connection. And for that reason, for larger workloads, we also recommend that customers have a dedicated line for disaster recovery if it's needed. One other kind of convenient feature that we can often leverage in our disaster recovery solutions is what we call pre-seeding. So outside of just your daily replication of the daily change rate is how do I initially get my data over to a service provider. You might have 20 terabytes of data and a 10 megabit upload. That would take weeks and weeks and weeks to do. So pre-seeding allows us to basically take a manual copy of the data and import it into our facility before we ever start replicating. So again, that's going to reduce the time and also the bandwidth costs. And pre-seeding can be very simple. In most cases, what we will do is actually FedEx you overnight an external drive that you copy your data onto, you overnight it back to us, we'll import it, and then start the replication. So it'll only replicate the delta data, which is going to be the data that changed since that copy was made to the disk. Another big consideration is after a failover is done, how do you redirect your users to a new location? In most cases, public-facing services have their DNS pointed at IP addresses that are going to be restricted to one location. The other is going to be maybe your users have a client VPN that they access or they work from home, and that VPN is directed at a specific location. While there's no one answer to this, there are a lot of methods that we can assist you with. The first and simplest is obviously going to be manual reconfiguration. This would be you logging into your registrar, changing the DNS entries so users can redirect. But that can often take a while depending on the time to live of your domain name and how quickly your users' DNS servers are updating. Another is going to be global site load balancers. So a global site load balancer is, think of a traditional load balancer that exists in multiple locations and is constantly reporting into each other. So if one site goes down, the other will notice that, and then traffic will only get sent to one location. Next is going to be a little bit of maybe DNS trickery, where you have multiple DNS zones in your domain, or multiple DNS servers configured. So if one is unavailable, DNS is automatically going to try another one. And then lastly, VPN tunnels. So if you have site-to-site VPN tunnels between multiple locations, we recommend running a second configuration of those tunnels that can easily be switched over. So you're not necessarily reconfiguring anything in a failover. You're just disabling the old one and enabling the new one. All right, and next is testing a DR solution. So I mentioned earlier that this is one of the most important things that we can help a customer do with their data protection solution. Is that a little quote for that? 48% of test recoveries fail. And this could be a lot of reasons. One, the data I'm replicating over there is corrupt. Maybe it's not working. Maybe it's incomplete. Maybe the infrastructure is not configured correctly. So I bring all the infrastructure online, but then it turns out nobody was updating the firewall configuration for the last 6 months, so all these rules are outdated and nobody can get to my services. We find that processes and procedures fail more than the technology. So testing is not just actually going in there and trying to bring your infrastructure up every once in a while, but it's continuous reviewing of your actual procedures. Do I have documentation that says when I make a change in production, I also have to consider my disaster recovery site and say, will this automatically replicate over, or do I need to make an actual change to my procedures? And then going back to the testing, in most cases, we can test without an impact to your production at all. This is often available self-service to the customer, but then again, of course, you can leverage the support of a service provider to bring your infrastructure online, make sure everything looks good, make any tweaks that you need to, and then reverse that protection. Now, really quickly, we'll go over a couple case studies for deployments we put together based on all the considerations that we just talked about. The first is for a large banking institution. One of the challenges with banking institutions is that you can't just have one main office. You still have these branch locations all over the place. Banking also has highly transactional workloads for all those financial transactions that have to get recorded somewhere. In this case, they had, they were mostly virtualized, but they still had a couple physical servers sitting around. And of course, a bank needs to be highly available, so they had RPOs of seconds and RTOs of minutes, so very little tolerance for downtime. What we did here was a combination of some of the products we talked about earlier. One was Zerto to replicate their virtual infrastructure from their primary facility up into ours. And then we also used DoubleTake for those physical servers. In this case, we replicated them from physical servers in their production to virtual servers running in our environment. I see we're coming up pretty close on our 30-minute time window. I'm going to keep going. If anyone's able to stay on, great. If you have to drop off, we absolutely understand. The next is going to be for an education system. In this case, it was the Colorado Community College System. They had, very similar requirements with a few different caveats. One is that they needed their Exchange to be highly available. So their system ran Exchange for their employees as well as their students, and they needed a student who was at home or in the dorms, doing homework to be able to check their email. They also had large SQL and Oracle databases as part of their ERP system. They were on a VMware infrastructure, large amounts of data. So all that, now we have online curriculums. They had the email. They needed an orchestrated recovery process. This is due to their ERP system, having multiple components: web servers, database servers, app servers. Your database server is no good if it comes up before your web server, that people use to access it. And then, of course, just like before, RPOs of seconds and RTOs of minutes. So in this case, what we did is actually deploy them a private cloud infrastructure in our facility, and this is a dedicated virtual environment. In this, we deployed a Exchange infrastructure with a distributed access group, and this allowed the Exchange to be up and running, highly available in both locations. So if one went down, users were able to access it to in the other site. Another thing we did, because they had so much data, and because they had SQL and Oracle databases residing directly on a SAN, we used some storage replication. So we replicated their EMC SAN over to a similar SAN in our environment. That way we were getting every bit of data on that SAN. Then we used an orchestration manager, such as Site Recovery Manager, to actually look at the virtual machines that were residing on the SAN. So the SAN data is there, it's live continuously. Site Recovery Manager allowed us to set orchestration workflows that say, bring up the application server, then the web server, then the database server, in that order, check to see if it's okay, and then continue on with these next steps. So it gave us a very specific level of detail. And then what are some of the metrics for providers? So going back to some more Gartner information, there are 8 critical capabilities that service providers must meet to provide an adequate solution. First is going to be customer experience. As we mentioned, 24/7, 365 support, available when you need us, but also making us available to help you design, test, and implement the solution. Physical virtual system recovery is covered by the variety of different products and solutions that we offer. Pricing, pretty straightforward, making this cost-effective for you to implement, so you don't have that large capital expenditure buying infrastructure. Instead, leveraging cloud-scale computing. Resiliency, that is something that's primarily built into our data center facilities, so redundant power, redundant internet carriers, redundant cooling systems. Security and compliance. We mentioned earlier that things like HIPAA and SSAE 16 SOC 2 compliance are very important to businesses. We maintain those compliances. That way you can leverage us as a partner and not have to worry about validating any of that. Service manageability is going to tie into us assisting you manage this. You are not on your own. You're not just purchasing these services through us. we help you manage them on a daily basis. Testing and declaration, covered that pretty well, and also value-added services. And what the value-added services means is a lot of people may come for a disaster recovery solution, but then they learn about some of the other services we can offer. These can be management services. Maybe they'll manage the firewall, manage the servers once they're failed over, or licensing, or security services like anti-malware on the servers, again, after you fail over. All right, and I know we ran just a little bit long, but that's all we have for the presentation. So I guess we can open the floor for questions if anyone's still around.
Looks like we're all good on the question front, Josh.
Okay.
So thank you, Josh, for presenting. Thanks, everyone who attended today. We will be sending out a recording. Feel free to share that along, and have a wonderful rest of your day.
Great. Thank you, guys.